So these notes cover two-dimensional figures. So we have a new vocabulary term here. A polygon is a closed figure formed by a finite number of coplanar segments called sides. The vertex of each angle in a polygon is considered a vertex of the polygon. So over in this polygon here, we have vertex A. Since it's just a point, we just name the point. This would be side BC. And since it's a segment, we use segment notation. And this whole thing is just called polygon. We're just going to name all 5 points. Polygon A, B, C, D, E. So here we have some examples of things that are polygons and things that are not polygons. So notice here that polygons are all closed. They're formed by specifically line segments. So this one right here is not a polygon because it's not closed. One important distinction is that they can't intersect itself. So this figure here is not a polygon because it intersects itself and it can't. You could technically say that the two triangles are polygons, but the whole figure at once is not. This one right here has curves on it, so no curves are allowed. Same thing with this one and this one. And then here it's because the segment extends past the figure. So over on this side we have things that are polygons. So notice none of them intersect themselves, they're all closed, and they're all formed strictly with segments. So a polygon can either be convex or concave. Convex polygon, so we'll draw a triangle. A convex polygon, if you extend the line segments, then it won't cross any other part of the polygon. So notice when I extend the segments on this triangle here, it doesn't pass through the polygon ever again. Whereas over in the concave side, if you have something like this, if I were to extend the segments here, then because they pass through the polygon again, that makes it concave. So a polygon can be named by its number of sides. For polygons greater than 12 sides, there's no special prefix. So over here on the table, we have common prefixes. Obviously, 3 sides is a triangle, 6 is a hexagon, things you know. Once you go past 12, you don't get any special prefixes anymore. So you just state the number of sides. So 15 sides is called a 15gon. We don't see those a whole lot, so they don't get fancy names. An equilateral polygon is going to have all congruent sides. And an equiangular polygon, you guessed it, will have all congruent angles. So a regular polygon we'll define using 3 terms we already talked about. A regular polygon is convex. It is equilateral. And it is equiangular. Okay, so down here we'll classify some polygons. So we're going to say whether it is convex or concave. We're going to name it, state whether it's convex or concave, and then regular or irregular just means not regular. So here, this polygon has 1, 2, 3, 4, 5, 6 sides. So that's a hexagon. It's going to be concave, because notice if I extend this right here, then it intersects the polygon again. That makes it concave. And because it's concave, it can't be regular. Because notice up here we said a regular polygon has to be convex, right? So it's going to be irregular. Here we have 1, 2, 3, 4, 5, 6, 7, 8. So that makes it an octagon. And this one is convex, because all of these sides will extend forever without intersecting the polygon again. Right? And notice all the angles and all the sides are congruent with the tick marks and the angle arcs. So that's going to make it a regular octagon. So some more things about two-dimensional figures is they have either a perimeter, an area, or a circumference. So the perimeter of a polygon is the total length of all its sides. So that's when you add up all the sides. Since a circle is not a polygon technically, because a circle is formed with a curve, it doesn't have a perimeter, but it has a circumference. And then the area is the total amount of space that a figure takes up. So we have some perimeter, circumference, and area formulas that you've seen many times before, I'm sure. Notice that perimeter for triangle, square, rectangular, it's really just add up the sides, right? So I have people that sometimes forget perimeter formulas, but as long as you remember, you're just adding up the length of the sides. And then here, these just you happen to be able to simplify by combining like terms on some of these. Circumference and area formulas get mixed up a lot for circles. The way I keep track of it is we know that area has to be square units, and the formula for area, you're squaring the radius, right? So find the perimeter and circumference. Find the perimeter or circumference and area of each figure. So the perimeter of this rectangle here is going to be 2 times 2.1 plus 2 times 3.2. This is the perimeter. That's going to come out to 10.6 centimeters. And the area is 3.2 times 2.1, which is 6.72 centimeters. These are square centimeters, meaning it's a 1 by 1 centimeter squared. For the circle, we don't have a perimeter, but we have a circumference. The circumference is equal to 2 times pi times the radius, which equals 2 times, we'll use 3.14 for pi, and the radius is 3, and we get 18.84 inches. And the area is 3.14 times 3 squared. Notice it's only the 3 that's being squared in this calculation. Some people mix that up. The squared is only applied to the 3. So this is really 3.14 times 9. And that comes out to 28.26 square centimeters. Okay, so that's it. Go do your test review now.